This program is made by the volunteers at Math Circle Online. Please join us to explore the wonders of math.
Hi, I'm Oliver Jiang, and today I'll be showing you how to solve problem number 22 from the 2015 AMC 8. So the problem reads, on June 1st, a group of students is standing in rows with 15 students in each row. So on the first day, the students are standing in some sort of formation, and in each row there are 15 students, and there is some number of rows. Let's call that C1. So we know that we do not know what C1 is, but we do know that R1 times C1 equals some number n, where n is the total number of students. Okay? So on June 2nd, the same group is standing with all the students in one long row. So on the second day, the formation now looks something like this. We know that there is exactly one row, so C2 equals 1, but we do not know what R2 is. What we do know is that R2 times C2 equals the same total number of students as on day 1. Okay? On June 3rd, the same group is standing with just one student in each row. So on day 3, the formation now looks something like this. R3 equals 1. C3, we do not know, but we do know that R3 times C3 equals the same n. On June 4th, the same group is standing with 6 students in each row. So on the 4th day, their formation has R4 equals 6 and some C4. And we know that R4 times C4 equals n. And this process continues through June 12th with a different number of students per row on each day. So this pattern continues with no single formation being repeated until we get to day 12, where they create some formation with R12 and C12. We do not know what these R12 and C12s are, but we know that R12 times C12 equals n. However, on June 13th, they cannot find a new way of organizing the students. So on day 13, there is no longer any new formation that they can form, which means that they have found every possible dimension that can be formed. What is the smallest possible number of students in the group? So the question is asking us to define the smallest possible n. This is what we're looking for. So the total number of students, n, can be written as some combination, some product of R and C. So because there are 12 different days, there are 12 different combinations of R and C, so there exist 12 different values of R, R1 through R12. Because there are 12 different values of R, n must have 12 factors. Okay, so n can be expressed as a prime factorization. So this prime factorization will look something like this. 2 to the power of a times 3 to the b times c, or 5 to the c times 7 to the d times 11 to the e, and so forth. So we can count the number of factors that n has with this prime factorization. We use the formula a plus 1 times b plus 1 times c plus 1 times d plus 1 times e plus 1, and so forth. So where this formula comes from the fact that given a factor of n, let's call that f, so f is is a factor of n. F can be prime factorized as 2 to the a0 times 3 to the b0 times 5 to the c0 times 7 to the d0 times 11 to the e0 and so forth. So the number of choices for a0, so a0 must be less than or equal to a. a0 must also be greater than or equal to 0. So the number of choices for a0 is a plus 1 because the total number of integers in this range is a plus 1. Similarly, the number of choices for b0 is b plus 1. For c0, it's c plus 1, and so forth. So we multiply the number of choices for each term, and we get this product. So we already know that the number of factors that n has is 12, so this product should equal 12. Let's factorize 12. So 12 can be written as 3 times 2 times 2. So one of these terms must be the 3, one of these terms must be the 2, another one must be another 2, and the rest are all 1s. So, how do we know which term is which? Well, because we want to minimize n, we want to maximize the power of the smallest base. So that means that we want to maximize a because 2 is the smallest one. So a plus 1 should be the 3. So that means that a equals 2. By similar logic, now that we have fixed what a is, b, we want to now maximize b. So b plus 1 should be the 2. So b equals 1. And we do this process again. So c plus 1 should be the 2. So c equals 1. And the rest of these are simply 1s. So d equals 0, e equals 0, so forth. So now that we know what these powers are, we can find what n is. So n equals 2 to the power of the 2 times 3 to the power of 1 times 5 to the power of 1, and then times a bunch of numbers to the power of 0, which is just 1. So that means that n equals 60. And so our answer is C, 60. We check our work first. We know that 15 must be a factor of our answer, and that is true. We also know that 6 must be a factor of answer, which is also true. So we know that our answer is correct. There's an easier way to do this problem. You could have simply guessed and checked with each of these values, just counted the number of factors, and that would have probably given you the answer much quicker. Thank you for watching.